Autonomous AI agents process tokens differently than standard chatbots, and without specific architectural safeguards, the costs scale faster than most project budgets can handle. This is the agentic cost multiplier effect. Every step in an agent loop re-injects the entire conversation history and tool schemas into the context window, causing your token consumption to grow exponentially with every iteration. If that loop fails to close, the financial impact is immediate. In one documented case, a runaway agent consumed 27 million tokens over 7 hours, racking up a $400 bill for a single failed task. Implementing 3 specific changes, first, iteration caps, next, model routing, and prompt caching, provides the control necessary to reduce these operational costs by up to 90%. The first and simplest safeguard is a hard iteration cap. This acts as the primary mechanical failsafe for any autonomous agent code. Within your execution loop, you must set a hard maximum limit of 10 to 15 iterations per task. Agentic costs scale linearly with every turn, but the probability of a successful outcome does not. If an agent hasn't solved a problem in 15 steps, it has entered a state of diminishing returns and is likely stuck. At the point of an infinite loop, the system is no longer engaging in logic. It is consuming your compute budget on a broken process. The second step is moving away from the default practice of sending every agentic turn to a high-cost frontier model. Instead, use a routing strategy. Simple tasks go through the green pipe to a mini-model, while the gold pipe reserves expensive reasoning for deep planning. A mini-model costs 15 cents per million tokens, a 94% discount compared to the $2.50 flagship rate. By matching task complexity to the appropriate model, you can execute significantly more agentic steps for the exact same budget without losing output quality. Finally, use prompt caching to separate your static system context from your dynamic user inputs. Format heavy data, like system prompts and tools, at the absolute beginning of the request. The provider computes this once, allowing subsequent loops to hit the cache for 90% discounts. You must keep this static. Adding a timestamp breaks the prefix, forcing a full-price read. With caching correctly implemented, your agent's core instructions function as efficient, low-cost memory rather than recurring overhead. Your agent is now protected from infinite loops, routing subtasks to cost-effective models, and recalling its instructions for a fraction of the standard price. These 3 optimizations drastically reduce the token-to-solution ratio, making even the highest volume agentic tasks economically viable for large-scale production environments. Run a test task and check your provider's billing dashboard. Look specifically for the cache read tokens line item to verify that the system is successfully retrieving data from the cache. Sustainable AI deployment requires keeping agent loops tightly closed and compute budgets strictly controlled.